Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight I'm doing a special video on dangerous Dorian. Dangerous Hurricane Dorian. The satellite image is an infrared image. It's an enhanced infrared image, and what we're looking at are cloud top temperatures. And the more maroon and that grayish color basically on the left side of the eye of Dorian, that indicates very, very cold cloud top temperatures, and very cold cloud top temperatures correspond with very tall clouds. Now, this is an extremely powerful storm. This could have impact to many, many people from the Florida Peninsula, along the eastern coast of the Florida Peninsula, all the way up into Georgia, the Carolinas, in parts of the Mid-Atlantic before Dorian is finally pushed out to sea. We have a lot to discuss about Dorian tonight, so let's get right to the discussion. First off, latest advisory as of 5 p.m. Eastern Daylight Time, today, 1 September 2019. Dorian's location was at 26.6 degrees north latitude, 77.3 degrees west longitude, about 95 miles east of Freeport, Grand Bahama Island, about 175 miles east of West Palm Beach, Florida, with maximum sustained winds at an incredible, just incredible 185 miles per hour. Now, when I mention the word sustained in front of winds, this is persistent winds. This does not even include the wind gusts. So we have a Category 5 storm in Dorian. The present movement is to the west, or 270 degrees at only 5 miles per hour. Dorian has slowed in the weakening steering currents over the last 24 hours, with an astounding minimum central pressure at 910 millibars, or 26.88 inches of mercury. Now, just to put the central pressure into perspective, the standard central pressure at sea level is 1,013 millibars. This is 103 millibars below the average standard sea level pressure. So this is really, really amazing. See how this storm has evolved. I go back to my title slide here of the enhanced infrared image and how clearly defined the eye is, where that air is sinking and warming at the center of the storm, and such a concentric, symmetrical shape. This is like a textbook looking storm right here. This is the National Hurricane Center official track, and please pay attention to these latest advisories by the professionals at the National Hurricane Center. They do their updates, there's advisory updates issued, 6 hourly updates issued. Please pay attention to the National Hurricane Center down there in South Florida. Now, as of 5 p.m., you see where the X is. That's currently where the Dorian is sitting right now, moving only 5 miles per hour to the west. The M indicates major hurricane. So a major hurricane has winds greater than 110 miles per hour. So if you see the M symbol, that means the storm still has greater than 110 mile per hour sustained, not including gusts, sustained or consistent winds. Right now, there's hurricane warnings issued for parts of the east coast of Florida. There's also a tropical storm warnings that were issued earlier. Looks like there's a tropical storm warning issued there for Lake Okeechobee as well in South Florida. So now look at how the curve of the official track and where Dorian's headed based on the latest Hurricane Center advisory. Look how the M's, those letter M's, the major hurricane status, how they bunch up between 5 p.m. Sunday and 2 p.m. on Tuesday. Very little movement. This is very bad news for the Bahamas. The northern Bahamas have really taken a beating today. And unfortunately, this major hurricane is not going to move out of the way very quickly. And then from 2 p.m. Tuesday up to 2 p.m. Wednesday, starts gaining a little more speed as it turns to the north, and more of a north-northwest wind vector, eventually going to turn toward the north-northeast, wrapping around a weakness in the ridge, basically situated in the vicinity of Bermuda. And then by 2 p.m. Friday, it's off the mid-Atlantic coast, off the Virginia-North Carolina border, and the white solid line with the little dash, the little white spots in it, indicates your cone of uncertainty. And so anybody in this cone is not out of the woods by any stretch. So everyone needs to pay very close attention to the storm. We do expect a weakening trend as is typical as Dorian moves in by the Carolinas and into the mid-Atlantic states above 35 degrees north latitude. That's usually where you start seeing what's called an extratropical transition, a transition from a tropical to extratropical storm. So I'll get more into that here in a minute, but this is the latest forecast track officially issued by the National Hurricane Center. This slide represents the wind speed probabilities on the left, and then the total rainfall outlook on the right. So the image on the left shows tropical storm force wind speed probabilities. Okay, the purple shading greater than 90% probability, and that's exactly what we'd expect based on the track of Dorian. The scale is at the bottom there horizontally, ranging from white color would indicate 0% chance, all the way to that purple shading, all the way up to 100% chance. So you can take a look and see how the coastal communities of Georgia, South Carolina, and North Carolina are really going to get brushed by Dorian based on the latest track. So there's going to be a lot of water, a lot of storm surge on the immediate coastlines of these multiple states. Florida, Georgia, South Carolina, North Carolina. Could be multiple storm surge situations going on across all these states. The image on the right again shows your 120-hour 5-day rainfall forecast in inches. And you can see the purple shading there on the right-hand image showing rainfall greater than 20 inches out over the northern Grand Bahama Islands, and then up into just off the coast over the water just east of Florida. And that stream of moisture, heaviest, is going to be associated with the path of Dorian as Dorian moves up the coastline, southeast coast, and off the mid-Atlantic. Now let's take a look at the two main global models that we're always talking about, the GFS model. We're going to start with that, and then we'll look at the European model. And then we'll take a look at a multitude of models and their tracks. So first, let's take a look at a two-panel image here of the GFS. And the image on the left shows the thickness chart where Dorian sits on the morning of Wednesday, September 4th, 2019. Dorian is expected to slowly weaken, not by much, but will weaken slowly as the storm moves north, makes that turn north. So basically, it's just east of Jacksonville on Wednesday morning, the 4th of September, with a central pressure of about 950 millibars. Okay. Image on the right, we move forward to the Wednesday evening at about 8 p.m. Eastern Daylight Time. Wednesday evening is the image on the right. Actually, it's Thursday. Actually, no, it is Wednesday evening. My bad. So Wednesday evening is the image on the right at about 8 p.m. Notice how Dorian is starting to make her turn now up to the north-northeast at 952 millibar pressure situated off the South Carolina-Georgia border. And some of that moisture is really getting flung in, a lot of onshore flow north of the storm center into South Carolina, and also beginning to move into North Carolina. Moving forward now to Thursday morning, September 5th, 2019 at 8 a.m. Eastern Daylight Time. Dorian is now slowly weakening to a 959 millibar low. Now, 959 millibars is still fairly intense. The black lines represent your lines of equal pressure, by the way, and when they're bunched really close together, that indicates a lot of wind on this particular type of chart. So there's a lot of heavy rain represented by the green colors, and the yellow and the oranges and reds represent the heaviest rain. So there's going to be very quick deteriorating conditions for parts of South Carolina and North Carolina, eastern North Carolina, on Thursday morning, the 5th of September. Image on the right, now Dorian has weakened to a 967 millibar low. So the central pressure is rising. which indicates a weakening trend. But keep in mind now, this system has been so wound up and so intense that there's still going to be a lot of energy associated with Dorian, even though it's weakening. So we're expecting very gusty northeast winds into southeast Virginia by Thursday evening. We're also expecting a banding feature of rain that's going to be moving in off the ocean. Moving ahead now to the wee hours, 2 a.m. on Friday morning, September 6th. This image on the left on the GFS shows Dorian now weakened to a 989 millibar system. So the pressure is rising rather rapidly at this point as Dorian starts losing tropical characteristics. Tropical characteristics being warmest temperatures at the center of the system. Okay, it's starting to make Dorian at this point starting to make a transition towards an extratropical cyclone, something that we see in the fall and winter, especially across the United States in the middle latitude westerly wind belt. So there's a lot of rain and wind. Conditions are still pretty bad overnight Thursday night based on the latest GFS track. Image on the right showing Friday morning, and the winds are finally starting to turn around more to the north-northeast, to the north here in the Hampton Roads area in southeast Virginia as Dorian begins to move out away from the mid-Atlantic coast. This is the GFS steering influences. This is something we have to really keep an eye on. This has been the biggest forecast challenge. If you've watched any of the coverage on the Weather Channel, or if you've been reading any of the National Hurricane Center discussions, but Dorian's been quite a forecasting challenge because you have a strong ridge over the top of Dorian initially, sending Dorian closer to Florida, but then there's a weakness in the ridge that develops. The image on the left shows that weakness, represented by the lighter orange color. So you've seen kind of like a orangish reddish color to the east of Dorian, and then also to the northwest of Dorian over the southeast U.S. That lighter orange color represents what's called a weakness in the ridge, and hurricanes are looking for the path of least resistance as far as their direction of movement. They want to take the easy way out, and the easy way out for hurricanes is through lowering surface pressures. They tend to follow the lowering surface pressures ahead of them. That's the path, as well as warmer ocean currents. And we have a warmer ocean current off the East Coast known as the Gulf Stream. So hurricanes generally, majority of the time in this position, they're going to basically move north and the northeast and basically parallel the southeast coast because the Gulf Stream generally runs southwest to northeast. But in this case, the image on the right shows that weakness in the ridge to the north of Dorian at the time. There's also, on the image on the right, a kink in the lines of equal pressure, a kink in the isobars. There's a 996 millibar low over southeastern Canada with a frontal boundary. Now, I don't have it drawn on here, but that's a frontal boundary that's extending southwest from that low pressure system. And there's a kink or a bending in the isobars over Michigan into northwestern Ohio, into central Indiana. All right, that's associated with a front, surface front, and also a upper level trough. Now, upper level troughs, if they are deep enough, in other words, if they dip down far enough, they can actually steer hurricanes away from the East Coast. Now, I am not seeing, I've been looking at the charts, I'm not really seeing a very strong upper level trough. It's a fairly weak upper level trough. And what may happen is, as that trough moves east, Dorian will eventually continue to move in the weakness of the ridge and basically look for the trough, but the trough is fairly weak. So there's going to be a surface front associated with this trough. And the problem I see is that front very well could stall out along the North Carolina-Virginia border, and that could be an even greater focal point for the moisture associated with Dorian. This happened in 2016 with Hurricane Matthew. Very similar path. I'll show you Matthew's path here in a few slides. But if you get a tropical system with just loaded with all this tropical moisture, tropical cyclone with all the moisture, and then it interacts with a stationary frontal boundary, any frontal boundary, it tends to, all that moisture gets spun around in a counterclockwise fashion around that tropical cyclone and is collected along the frontal boundary, and that could result in enhancement of the rainfall. So I am concerned about this. I'll show you a map of the boundaries here in a little bit. Now let's move to the European model track. The image on the left shows 8 a.m. Eastern Daylight Time, Wednesday morning, 4th of September. The Hurricane Dorian, is situated just east-southeast of Jacksonville, Florida. It remains parallel to the coastline, the Florida coastline, never really makes it into Florida for landfall. Image on the right shows a Wednesday evening at 8 p.m. Eastern Daylight Time. Dorian begins to make a move further north, basically just east of Jacksonville, Florida on Wednesday evening. Okay. Moving along. Now the image on the left shows you 2 p.m. Eastern Daylight Time on Thursday, 5th of September. And Dorian is weakening as the storm moves now more north-northeast, almost as if it's moving parallel to the coastline. It still did not go into Georgia, did not make landfall there. It's now just off the coast of Charleston, South Carolina on Thursday afternoon, early in the afternoon. Image on the right shows Dorian now moving just off the coast of Wilmington, North Carolina. And there's a lot of rain associated, getting wrapped around all along the coast as Dorian moves up the coast. Image on the left on this slide shows Dorian's position at about 8 a.m. Eastern Daylight Time on Friday, the 6th of September. And conditions are very rough at this point. There's a lot of wind, a lot of rain, especially for eastern North Carolina, Outer Banks. Dorian is nearly about to make landfall over the Outer Banks on Friday morning at 8 a.m. Eastern Daylight Time, according to the latest European model. And then the image on the right shows Dorian starting to move northeastward away from the coast, but before it does so, there will be impacts up into southeast Virginia, especially in the Virginia Beach area. The European steering influences, let's take a look. Looking at 500 millibar charts here on the left and right. The 500 millibar level is about 18,000 feet above the ground, and the middle level is the atmosphere. Vorticity charts is what I'm showing you, along with the black saddle lines, which are your height contours. Generally, the image on the left, Thursday morning, the 5th of September, shows a bending of the height lines, height contours, generally to the north of Dorian, which is associated with the upper level trough, which I had already mentioned in the video here. But will that upper level trough be deep enough, or will it just simply be weak and lift out and not really impact Dorian's track? Will the weakness of the ridge, the orientation of that weakness, how will that be orientated? In this case, the weakness of the ridge is oriented in a south-southwest and north-northeast line. Notice how Dorian on the right, the center of Dorian, is now basically over the Outer Banks on Friday morning at 8 a.m. Eastern Daylight Time. So there's a lot to talk about here. These are the steering influences, the weakness in the ridge, and then the approaching trough. How deep does that trough get? Now this is the GFS on the left and the European on the right. These are ensemble tracks. So you can kind of get a look to see the GFS. There's a lot of different initial conditions at the beginning of the model run, and the tighter these are clustered, these lines, the greater the confidence or likelihood of the storm making this turn. So we notice a gradual north turn east of the Florida coastline, then becoming northeasterly off the South and North Carolina coastlines. Okay. Image on the right shows the European, which is closer, has a closer track to the coastline. It's further to the northwest. So this is something that really got to look at. The farther apart these lines are, the lower the confidence levels. The more tightly packed they are, the greater the likelihood of this track happening. So this is just a look at these two. Now this is all model tracks. So there's a lot of various models there on the right-hand side of the image that show different possibilities. And again, just like the ensemble tracks, the more closely packed or tightly packed these lines are, these different color lines are representing the different models, the higher the confidence of something happening. So we have a pretty high confidence of a track that runs parallel to the east coast of Florida, runs parallel to the coast of Georgia, South Carolina, gets very close to making landfall or passing right over the top of the Outer Banks, very close, and then moves out to sea, continuing, it'll eventually speed up once it gets caught in the westerly winds, especially in the higher wind speeds of the jet stream. It'll get pushed along much quicker once it gets north of 40 degrees north latitude. All right, I did mention this earlier, but this looks like a track very similar to Hurricane Matthew in October of 2016. The part that's very similar, obviously, it's not the southern part of the track, but it's a track basically paralleling north of the Bahamas, paralleling the east coast of Florida, and then turning to the right or to the northeast. This looks very similar to the current forecast track for Hurricane Dorian. Now, there were a lot of impacts. You do not have to be experiencing a landfall. You don't have to experience that landfall, the hurricane to come in over your head, to really feel the impacts. There's tons of beach erosion with pounding waves and pounding surf that could be felt. There's a lot of winds that can impact the immediate coast with a push of storm surge north of the center of the storm, excessive push of storm surge or higher water levels coming inland. So there, heavy rain is another possibility. So there is a very big similarity between Matthew and then this particular storm, Dorian, and the models are really locking into a possible solution. Now, it does not mean they can't change, because they can. All right, so now let's look at Hampton Roads, Southeast Virginia. This also shows Northeast North Carolina if you live in that area. This is the wind forecast according to the European track. Now, keep in mind the European track, the image on the left shows that is 11 a.m. Eastern Daylight Time on Friday, the 6th of September. The bottom right shows a little concentric circle. That's actually Dorian's center. Okay, beginning to make an extratropical transition. I'll get into that more in a minute. But these are the wind speeds. These are the sustained winds, not the gust. Sustained winds. The image on the left shows 35 to 45 mile per hour wind gusts into southeast Virginia, from Norfolk down to Virginia Beach. And then there's even stronger winds down into the Carolinas, into the northeast North Carolina, especially around the Outer Banks. The image on the right shows a little bit later in the day on Friday, the 6th of September, about 2 p.m. Eastern Daylight Time. The storm begins pulling away at that point, and you're getting a strong northerly wind now into southeast Virginia, 25 to 35 mile per hour winds. Now, there's going to be gusts higher than this. Okay. Now we're looking at the gusts. Okay, so this was the sustained wind. This is the constant blowing wind. 35 to 45 miles per hour. Generally, that's a good call right now based on what we're seeing on the model. These images here show wind gusts. So the image on the left for 11 a.m. Eastern Daylight Time on Friday morning, the 6th of September, shows 70 to 75 mile per hour wind gusts over Hampton Roads in southeast Virginia. 60 to 70, occasionally higher than that, 90 up to just 90 miles per hour down off the Outer Banks. So this could be very strong. Image on the right shows 2 p.m. Eastern Daylight Time on Friday the 6th of September wind gusts. And those are still at 55 to 60 miles per hour for Norfolk, Chesapeake, Virginia Beach. Stronger winds closer you get to the beach. And then 65 to 70 mile per hour wind gusts down over northeast North Carolina. So again, this is going to be an interesting scenario if it does develop. GFS winds forecast. Now this is off the 12Z model run today on the 1st of September. I haven't really looked at the 18Z yet. It had just come in. generally showing you the positions of Dorian as Dorian transitions to a mid-latitude extratropical cyclone, but very strong wind gusts again showing up on the GFS. Actually, these are winds, not gusts. So these are straight up sustained winds again. But generally, you're looking at anywhere from 24 to 38 mile per hour winds. And on the right hand image, a little bit later on Friday, the 6th of September, the winds remain generally in the same area, generally 30 to 40 miles per hour as Dorian moves basically just parallel to, after moving over Outer Banks, starts moving northeast. Now, these are the rainfall totals that we're expecting. In Hampton Roads, we're looking at anywhere from 3 to 5 inches of rain. Heavier rain amounts down towards northeast North Carolina could range anywhere from 6 to 8 inches. Now, this is just based solely on the 12Z, the midday European model run. That's the image on the left. The image on the right shows the GFS midday model run for the 1st of September based on that latest track, showing rainfall amounts of 8 to 12 inches, 8 to 12 inches, a little bit higher rainfall amounts over northeast North Carolina, and then possibly 6 to 8 inches over Hampton Roads cities. Heaviest will be down towards Virginia Beach. Right, so this is what I was really concerned about. Okay, this is what I'm really concerned about. This happened with Matthew in October 2016, and now Dorian is coming up the coast. And we get this frontal system there on the left-hand image. You see the blue line with the triangles. And then you have the little red half semicircles. That's a stationary frontal boundary. There's high pressure situated over Michigan at 1024 millibars. But then you've got Dorian pushing up from the south. You're going to get this very strong, what we call pressure gradient, or a very large change in pressure. And that's going to result in a lot of northeasterly winds. Right? But that front gets hung up. Look in the image on the right. That's on Friday morning. The image on the right is Friday morning. And Dorian is transitioning to an extratropical cyclone along the frontal boundary. Now, what is the difference between a tropical and extratropical cyclone? There's a couple big differences. First of all, with a tropical cyclone, the warmest temperatures are at its center. Okay, that's a warm core low. With an extratropical cyclone, the coldest temperatures are towards the center. Okay? So it will transition from a warmer core to a colder core with time and become entrenched along this front. And the difference between a tropical and an extratropical cyclone, also that's pretty significant, is the wind field and how it's distributed. It becomes more elongated, the wind field. It expands in size outward from the center. Additionally, what you have is you have an asymmetrical shape to the storm. See, right now, as a hurricane, Dorian is very symmetrical or circular in shape. But over time, as it makes a transition from a tropical to extratropical low, it's going to become more stretched or elongated looking. So very important stuff. Now what happens, a front is already an area where air rises along it. It's a focal point for rising air motion. And then you throw a tropical system transitioning to an extratropical system, and all that moisture associated with the whole process along a stalled frontal boundary or stationary frontal boundary, you can have a lot of lifting in the atmosphere and a lot of rain. So we're going to have to see how the front interacts with Dorian. So these are my thoughts right now on Hurricane Dorian. Okay, we still have a highly uncertain track beyond the 3-day period. Now, we are starting to get a little bit more higher confidence in the model guidance. I've watched the model guidance the last 24 hours, and there's been very little change in the forecast track for Dorian. Now, with that being said, we still have uncertainty beyond 3 days. Things can change. The positioning, strength, orientation of that trough as it comes down from the upper Midwest, the weakness in the ridge, the orientation and the timing and strength of that ridge, can also change. So it still remains highly uncertain to track. We are gaining better confidence because the models the last 24 hours have been pretty solidly locked on to the track I've shown you in tonight's video. We're just going to have to keep an eye on it. All right. So that approaching trough and the weakness in the ridge, the positioning, the timing and strength are very critical. The forward motion of Dorian, very critical. All right. A lot can happen between now and Thursday. So please continue. Models have been more consistent over the past 24 hours. We've seen a slight shift to the west today, which could potentially have a greater impact on Northeast North Carolina and Hampton Roads cities, but it is most likely going to change again. We may wake up tomorrow morning and Dorian may be further out to sea, and the impacts may be much less. We could wake up tomorrow morning and Dorian might have shifted further west with a landfall into Wilmington, North Carolina, in a general track towards the north, or possibly north-northeast. So just keep in mind that just a slight shift either west or east that could have very significant consequences to our sensible weather here at the surface where we live. So right now as of 6 p.m. Eastern Daylight Time on the 1st of September 2019, based on the forecast track that we're seeing, this is my Hampton Roads forecast, or what we may expect to see. And we're mainly looking at a Thursday to Friday time period. The timing is a little bit too tricky right now, but I will say that it's somewhere in that window, Thursday to Friday. Okay? So right now, based on the current forecast track of Dorian, rainfall totals are 3 to 5 inches in Hampton Roads, with locally higher amounts, especially towards Virginia Beach. Closer to the southeast portion there, closer to the North Carolina, Virginia border, closer to the ocean, you're going to have higher rainfall totals. The winds will be northeast. That's not good news for Hampton Roads. And the reason it's not is because if you get a high tidal cycle where tides are running above normal as far as height, in addition to a persistent northeasterly wind blowing in off the Atlantic, that's going to allow water to reach higher levels on high tidal cycles from the Atlantic and flood some of the local streets in Hampton Roads, cities such as Virginia Beach, Norfolk. Okay, so northeast winds, not a good thing. Eventually those northeast winds will become northerly from the north. Right now we're thinking 25 to 35 miles per hour. I am going to adjust that now. I believe it's going to be 30 to 40 miles per hour. Northeast and north winds at 30 to 40 miles per hour with gusts 55 to 60 miles per hour in Virginia Beach, especially as you get closer to the ocean. The closer you get down along the water down towards the outer banks, the higher those winds are going to become. The higher wind gusts to 60 miles per hour are going to be at the beach. We're going to expect to see moderate to possibly major tidal flooding with a strong pressure gradient, with the northeast winds being directed along that pressure gradient. So moderate to major tidal flooding is possible. Now, once the winds shift to the north, that should help the situation a little bit. Eventually, they'll go north and northwest as the Dorian moves further out away from the mid-Atlantic. Transition from a tropical to extratropical system is very likely with Dorian. The storm's wind field. This is another thing. The storm's wind field typically expands or gets larger, spreads out, and becomes more asymmetrical over time. That's going to be a big factor to consider, because right now, with a symmetrical shape there in the Bahamas, Dorian's tropical storm force winds may only extend out to 100 miles from the center. But once it continues to weaken and move north, those winds are going to, the energy that was once concentrated at the center of Dorian is going to expand outward away from the center along with that wind. So we have to keep an eye on that. Pay close attention to the latest advisories from the National Hurricane Center for the latest information. And then have a plan in place in case the storm impacts our area in Southeast Virginia. Don't wait to the last minute. Make sure you have enough water. prepare for power outages, because that's a definite possibility with those kind of winds. We could see power outages, so you want to have a plan in place. Check your generators in case you need to have power back in the house restored, because Dominion Energy does their best in restoring power during storms. But if there's a lot of outages due to the winds, it could take a little bit of time. So now's the time to prepare. Now's the time to have a plan and to pay attention to the latest advisories from the National Hurricane Center. We will also be providing updates to you as throughout the day. So please keep an eye to Spot On Weather for the latest updates. And we do our updates in Facebook as well as Twitter. That's our primary methods that we put the latest information out. All right, that wraps things up at Spot On Weather tonight on this special video on Hurricane Dorian. Really uncertain. I would still say uncertain. The models are coming into better agreement over the last 24 hours, so there's higher confidence there. But that does not mean the timing of the trough, the weakness in the ridge orientation, those could easily change between now and Thursday, and that is going to have a significant bearing on the ultimate track of Dorian. I really, at this time, we will see some impacts, obviously, based on the track. But again, that could change. All right, that wraps things up. Spot On Weather. If we're not spot on, we're not doing it right. Have a great evening, everybody.